Imagine a grand symphony orchestrated by an infinite ensemble of stars, planets, and moons all performing in cosmic harmony. Yet, amid this celestial concert, one section continues to captivate astronomers like no other. Exoplanets. Exoplanets are simply planets that exist beyond the bounds of our solar system, hidden deep within the vast expanse of the Milky Way and among the endless sea of stars. They are planets so uncannily similar to Earth, so familiar yet mysterious that they may be our planetary counterparts. One of the most intriguing among them is Proxima Centauri B, located just 4 light years away. Thanks to the James Webb Space Telescope JWST, our journey to understand these enigmatic worlds has taken a revolutionary leap forward. This marks a new era cosmos full of possibilities. Now, imagine your thoughts soaring through the immense galactic arms of the Milky Way, a galaxy that may harbor over 250,000,000 exoplanets, a number with 15 zeros. To put that into perspective, if each exoplanet were the size of a grain of sand, we wouldn't just fill the Grand Canyon. We'd construct the Grand Canyon to point zero, a monument of staggering proportions carved from cosmic dust. Even more astounding is that roughly 20% of these planets are believed to be Earth-like, similar in atmospheric composition and geological structure. That means for every 5 exoplanets, one might have the right conditions to support life, and orbiting these worlds, possibly another 250,000,000 moons, each a celestial companion in gravitational dance. If you've ever dreamed of discovering another world capable of nurturing life, the universe offers not just a few options, but a torrent of them. Enter the celestial maestro, the James Webb Space Telescope, to explore such immensity. We need more than curiosity, we need vision. Enter the James Webb Space Telescope, our all-seeing sentinel in space. With its massive 6.5-meter segmented primary mirror, JWST collects more light and detail than any telescope before it. Dwarfing even the legendary Hubble, it can detect the faintest flicker of a star billions of light years away, or the subtle glow from an alien planet. What sets JWST apart isn't just its size, but its cutting-edge instrumentation, state-of-the-art sensors and spectrographs that can break down light into a wealth of information. These tools allow scientists to determine whether a distant planet contains water, carbon, oxygen, even organic molecules without ever setting foot on it. JWST isn't just a cosmic eye, it's a celestial lab, a detective that deciphers the chemical signatures of alien worlds. It doesn't merely observe the universe, it analyzes it with unmatched precision. Focus on Proxima B, our closest Earth analog, among the most fascinating targets in this new golden age of space observation is Proxima B, discovered in 2016. This exoplanet lies just 4 light years from Earth, a mere neighbor in cosmic terms. If we could somehow travel at the speed of light, we'd arrive in just over 4 years, the time it takes your favorite TV show to complete its run. Finding a potentially habitable planet so close is like stumbling upon a rare gem in a mountain-sized haystack. Proxima B orbits its red dwarf star within the habitable zone, where temperatures are just right for liquid water to exist, neither boiling hot nor frozen solid. Imagine streams winding through lush valleys, waterfalls tumbling over rocky cliffs, and oceans as deep and enigmatic as the Mariana Trench. Yet, Proxima B is not without its mysteries. One day on Proxima B lasts about 11 Earth days. This means sunrises, afternoons, and sunsets stretch on for hours, perfect lighting for photographers. But a biological riddle for humans. How would our bodies adjust to such elongated cycles? Would our sense of time, sleep, or even metabolism evolve to meet this strange new rhythm? Nature, it seems, has handed us a riddle wrapped in another, testing the very limits of what we define as habitable. How do we study a world we've never touched? Here's where JWST once again proves indispensable. Like a cosmic Swiss Army knife, it provides scientists with every tool necessary to analyze distant worlds. By studying how light passes through or reflects off a planet's atmosphere, JWST can identify its chemical makeup. Each molecule absorbs or emits light at specific wavelengths, allowing scientists to decode a planet's composition, atmospheric pressure, and temperature, just as a doctor might study a patient's vitals from a blood sample. In essence, space science has become cosmic forensics. We're not just observing the stars, we're gathering evidence, forming hypotheses, and unlocking the chemistry of alien worlds. The signal that shook the stars thing came a moment that could have been pulled straight from science fiction. While observing Proxima B, JWST detected a highly structured electromagnetic signal of potential technosignature, something possibly created by intelligent life. The world held its breath, and then, just as suddenly, the signal vanished never to repeat. Was it a glitch, a natural phenomenon, or something more profound? A brief, intentional transmission from an advanced civilization? No answers, only questions. But one thing is certain: Proxima B now stands at the center of a growing mystery, the next frontier, artificial illumination. Story doesn't end there. Scientists, led by researchers at Harvard, are now using JWST in a bold new way to search for city lights. Yes, artificial illumination on the night side of exoplanets. They're looking for patterns of light glows and grids that could suggest large-scale infrastructure, perhaps even civilizations illuminating their world just as we do ours. Imagine detecting the cosmic equivalent of New York City shimmering on a distant planet, its glow radiating across oceans and mountains. This pioneering approach signals a shift in how we search for life. It's not just about habitability anymore. It's about civilization detection. The future of exoplanet exploration as our technology evolves. So does our reach into the stars? We are no longer limited to dreams or distant hopes. We have instruments like JWST, part telescope, part laboratory, part time machine, allowing us to decode the secrets of the universe. With every observation, we inch closer to answering one of humanity's oldest questions. Are we alone in this unfolding cosmic epic? Exoplanets like Proxima B are not just rocks orbiting faraway stars. They are chapters in the greatest story ever told, the story of life, of discovery, and of our place in the cosmos. Ongoing advancements in cosmology and space exploration have led to the discovery of numerous exoplanets that may possess conditions suitable for life. Thanks to instruments like the James Webb Space Telescope, biosignature detection technologies, and ground-based observatories, our ability to identify and investigate distant worlds has grown tremendously. One of the most compelling areas of research focuses on exoplanets located within the habitable zones of their stars, the so-called Goldilocks regions, where temperatures might allow liquid water to exist. As our reach into the cosmos expands, so does our capacity to explore the unknown. Like cosmic detectives, we probe the vast frontiers of space, driven by a desire to uncover truths that could redefine our understanding of life itself. An enduring sense of wonder propels this journey, a belief that the universe still holds miraculous secrets waiting to be discovered. Space exploration remains one of humanity's most profound intellectual pursuits. Fueled by insatiable curiosity, we venture farther than ever before. With the unprecedented vision of the James Webb Space Telescope, our understanding of the universe is evolving rapidly, and with it, the tantalizing possibility of discovering life beyond Earth. What makes the study of exoplanets so thrilling is not just the discovery of new worlds, but the transformation of our understanding of what it means for a planet to be habitable. As we peer deeper into space, we are forced to ask bold questions. Must life require Earth-like conditions to thrive? Could it exist in environments vastly different from our own? In worlds with searing temperatures, high radiation, or toxic atmospheres, the discovery of extremophiles on Earth, organisms that flourish in boiling hot springs, under crushing oceanic pressure, or in acidic environments, has already revolutionized our view of life's resilience. These remarkable life forms suggest that living systems might be possible in places once dismissed as uninhabitable. The possibility of discovering alien life now feels more plausible than ever. Adding to this momentum, breakthroughs in artificial intelligence and machine learning are transforming how we interpret the immense volumes of data gathered from distant stars and planets. These technologies help astronomers detect subtle patterns and identify promising exoplanet candidates with extraordinary precision, dramatically accelerating the search for potentially habitable worlds. Future space observatories may bring us closer than ever to answering one of humanity's most profound questions. Are we truly alone in the universe? The grand journey of discovery continues to unfold. At the same time, the concept of technosignatures, artificial indicators of advanced civilizations, has sparked renewed scientific interest. What if we're not just searching for biological traces of life, but also for evidence of intelligence? Could unusual light patterns from distant exoplanets be intentional signals from other civilizations? The recent detection of an unexplained signal from Proxima B reminds us that the universe may still hold astonishing surprises, challenging our assumptions about the limits of life. If the James Webb Space Telescope, with its unmatched sensitivity and state-of-the-art technology were to detect even the faintest hint of extraterrestrial intelligence, it would mark one of the most monumental discoveries in human history. The confirmation of alien life, whether microbial or sentient, would fundamentally reshape our understanding of existence and force us to reconsider everything we thought we knew about life, the cosmos, and our place within it. As humanity continues this extraordinary journey of exploration, we must also reflect deeply: what is our role in this vast, ever-expanding universe? Should we attempt to communicate with intelligent life if we find it? And what responsibilities must we uphold as we explore worlds beyond our own? Space exploration is not only about seeking signs of life on distant planets, it is also a quest to understand the very nature of humanity. The future of this endeavor promises wonder, discovery, and the potential for revelations that could redefine everything. We are standing at the dawn of a new cosmic era, an epic just beginning.